Hello students, it's Kailash. In this video session, I'll be teaching you a shortcut method to balance a chemical equation. Traditionally, we follow trial and error method to balance a chemical equation wherein we place certain numbers in front of the molecular formulae of reactants and products, and we keep changing those numbers until we find an appropriate set of numbers which would perfectly balance the equation. Whenever this trial and error method, whenever you find a very tough time with this trial and error method, don't hesitate to follow this shortcut method. And this method involves a little mathematics. So you will never go wrong in this method, the shortcut method, as long as you don't commit any careless mistakes in between. So what is the shortcut method? Now, before going into the shortcut method, we shall see what is a balanced chemical equation. A chemical equation is said to be a balanced equation if the number of atoms of each element on the reactant side and product side are equal to one another. Suppose if in a chemical reaction, there are 2 sodium atoms in the reactant side, then there should be 2 sodium atoms in the product side. If there are 15 oxygen atoms in the reactant side, then there must be 15 oxygen atoms in the product side. So thus, if the number of atoms of all the elements involved in a chemical reaction are equal on either side, then we call such a chemical reaction as a balanced chemical reaction or a balanced chemical equation. Now, an unbalanced chemical equation is otherwise called a skeleton equation. Now, we will just see one example of a balanced and an unbalanced equation, and then we will go into that shortcut method. So here we have Fe, iron, reacting with nitric acid, HNO3, to give ferrous nitrate, FeNO3 twice, ammonium nitrate, NH4NO3, and water, H2O. Remember, NO3 twice, if I expand this, I'll be getting N2O6. The number 2, what do you find in the subscript of the radical NO3, nitrate radical, is common for nitrogen as well as oxygen. So NO3 twice on expansion is going to give me N2O6, which implies there are 2 nitrogen atoms and 6 oxygen atoms. Okay. Now we will just check whether this is a balanced equation or unbalanced equation. In the reactant side, we have 1 iron atom, and in the product side, we have 1 iron atom. In the reactant side, we have 1 hydrogen atom, and in the product side, we have 4 hydrogen atoms over here and 2 hydrogen atoms over here. So totally it makes 6. As far as nitrogen is concerned, we have 1 nitrogen atom in the reactant side and 2 nitrogen atoms in ferrous nitrate, 2 nitrogen atoms in ammonium nitrate. So that makes totally 4. And as far as oxygen is concerned, we have 3 oxygen atoms on the reactant side, and here we have 6 oxygen atoms. Here we have 3, so 6 plus 3 is 9, and here we have 1 oxygen atom in water. So totally there are 10 oxygen atoms. So the number of atoms of all the elements on either side are unequal. Iron atoms are equal, but what about hydrogen, nitrogen, and oxygen? They are unequal. Hence, this equation is an unbalanced equation. Now, for balancing this, I place numbers 4, 10, 4, 3 in front of iron, HNO3, ferrous nitrate, and water respectively. And I would have found these numbers after several attempts. If you have a good chemistry between you and chemistry, you will be able to find this appropriate set of numbers in a jiffy. And if the chemistry between you and chemistry is weak, then it will take a very long time for you to find this appropriate set of numbers. So it will consume much time for balancing the chemical equation by trial and error method. So in such cases, you can very well follow the shortcut method if you find it much more easier than your trial and error method. Of course, it's going to be much more easier. Now, we'll check whether this is balanced or unbalanced again. There are 4 iron atoms on the reactant side, and we have 4 iron atoms on the product side. And there are 10 hydrogen atoms on the reactant side, and we have 4 hydrogen atoms over here. And we have 6 hydrogen atoms over here. 3 2s are 6. you have to multiply the number of molecules. Here 3 refers to number of molecules of water. So I have to multiply 3 with the number what you find in the subscript of the symbol of the element. So to get the total number of atoms. So we have 3 molecules of water. 1 molecule of water will have 2 atoms. Therefore, 3 molecules of water will have 3 2s are 6 atoms. So number of hydrogen atoms, here we have 4 and here we have 6. That makes totally 10. So number of hydrogen atoms are also equalized on either side along with the ion atoms. And nitrogen, there are 10 nitrogen atoms on the reactant side. In the product side, we have, here we have 2 nitrogen atoms in 1 nitrate, isn't it? So here we have 2 nitrogen atoms and we have 4 molecules of ferrous nitrate, which makes totally 8 nitrogen atoms. 4 2s are 8. So we have 8 nitrogen atoms in ferrous nitrate, and here we have 2 nitrogen atoms. So that makes totally 10 nitrogen atoms. Hence, nitrogen atoms are also equalized. And what about oxygen atoms? Here we have 30 oxygen atoms on the reactant side, and we'll check in the product side. So we have 3 2s are 6 oxygen atoms in 1 molecule of ferrous nitrate. We have 4 molecules here. So 6 4s are 24. So there are 24 oxygen atoms in ferrous nitrate, 4 molecules of ferrous nitrate, and we have 3 in ammonium nitrate, and we have 3 1s are, if you don't find any number in the subscript of the symbol of the element, you should take it as 1. So 3 1s are 3. So that makes totally 30 oxygen atoms. Since all the elements involved in this chemical reaction are equal in number with respect to their number of atoms on either side, this equation is a balanced chemical equation. Okay, now we'll go into the shortcut. We'll see 3 examples. We'll start with a very, very simple equation. Water, it's elixir of life. So let me start with water. Hydrogen, H2, reacts with oxygen, O2, to give water. If you look at the number of hydrogen atoms and oxygen atoms on either side, there are 2 hydrogen atoms on the reactant side and 2 hydrogen atoms on the product side. Fine. Number of hydrogen atoms is fine. And what about oxygen atoms? There are 2 oxygen atoms on the reactant side, but there is only 1 oxygen atom in the product side. Hence, this equation is an unbalanced or skeleton equation because number of oxygen atoms are unequal on either side. Now to balance this, what I'm going to do is I'm just going to place A in front of hydrogen, B in front of oxygen, the molecular formula of oxygen in fact, and C in front of the molecular formula of water. So instead of placing numbers, I'm going to place the alphabets A, B, C, and if I have one more product, we can add D, and if I have one more product, we can add E. So A, B, C, D, E, etc. So these alphabets has to be placed in front of the reactants and products. And assume after placing A, B, C, after placing A, B, and C, let us assume this equation has got perfectly balanced, which means the number of hydrogen atoms on either side and number of oxygen atoms on either side are equal. Okay. Okay. Now, what I'm going to do is I'm going to keep A as such, and I'm going to write B and C in terms of A. That is, I'm going to find an expression for B in terms of A, whether B is half of A, or whether B is twice that of A, or whether B is thrice as that of A, and so on. So keeping A as such, write an expression for the rest of the alphabets, B, C, D, etc. in terms of A. Now, since this equation, after placing A, B, C has got perfectly balanced, so let me use the condition for a balanced equation. That is, number of atoms on either side has to be equal. Now, how many hydrogen atoms are there in the reactant side? There are 2A hydrogen atoms, A molecules of hydrogen. One molecule of hydrogen contains 2 atoms. Therefore, A molecule should contain 2A atoms. Suppose instead of A, if we have 3 here, what would have done? You have multiplied 3 with 2, isn't it? So just like that, I'm multiplying A with 2. So there are 2A hydrogen atoms in the reactant side, and there are 2C hydrogen atoms in the product side. Thus, since this equation is perfectly balanced, number of hydrogen atoms on either side has to be equal. So 2A should be equal to 2C. So 2A equals to 2C. So cancelling 2. Let me cancel 2 on either side. Dividing both sides by 2, 2 gets cancelled. So hence I get A equals to C. So successfully, I have found an expression for C in terms of A. So instead of C, I can use A. Likewise, number of oxygen atoms should also be equal because this equation is a perfectly balanced equation. You have 2B oxygen atoms on the reactant side and C. You have 1 here. So C into 1 is C. So C atoms of oxygen in the product side. Since this equation is a perfectly balanced equation, number of oxygen atoms has to be equal on either side. So 2B has to be equal to C. I need to write B in terms of A. I have got B in terms of C, isn't it? So already we have found C to be equal to A. Therefore, I can write 2B is equal to A. This implies B is equal to A by 2. So successfully, I have written B and C in terms of A. So what should I do next? So let me write that unbalanced equation once again, and let me keep A as such. Instead of B, I'm going to substitute A by 2. And instead of C, I'm going to substitute A because C is equal to A. Now dividing all the reactants and products by A because A is common. So dividing all the reactants and products involved by A. So if I divide it, A gets cancelled. So there is no need of dividing, just mention cancelling A. So I have 1 here and 1 by 2 in front of oxygen and 1 in front of water. So thus it becomes 1H2 plus half O2 gives 1H2O. So we have 1H2 plus half O2 which will give 1H2O. To eliminate this fraction, I have to eliminate this fraction. To eliminate this fraction, what I'm going to do is I'm just going to multiply all the reactants and products or the numbers what I find in front of the reactants and products with the term in the denominator. Suppose if we have two fractional values, suppose if we have 3 by 4 over here, in such cases, you just multiply the numbers in front of the reactants and products by the LCM of these two fractions, denominators or LCM all எல்லாத்தையும் multiply பண்ணுங்க. So I have to multiply with the LCM of the denominators of these two fractions with the numbers in front of the reactants and products. Okay, right. So if it is 1 by 2 and 3 by 4, the LCM of 2 and 4 is 4. So I have to multiply all the reactants and products by the number 4. So here there is only one fraction. Therefore, I'm going to multiply the entire equation by 2 to eliminate this fraction. So multiplying by 2 throughout. So 1 into 2 will be 2H2 plus, if I multiply this by 2, so 2 will cancel off. Therefore, I will have one oxygen atom, so O2, which would give, if I multiply this by 2, I will end up with 2H2O. Is it clear? So 2H2 plus O2 gives 2H2O. Now, this is a balanced equation. If you check the number of hydrogen atoms, we have 4 hydrogen atoms on the reactant side and 4 hydrogen atoms on the product side. We have 2 oxygen atoms on the reactant side and 2 oxygen atoms on the product side. So thus, we get a balanced equation. I hope you would have understood this method. We'll go with one more example. So we have cupric chloride, CuCl2, reacting with silver nitrate, AgNO3, to give cupric nitrate, CuNO3 twice, and silver chloride, AgCl. Remember, NO3 twice on expansion is going to give me N2O6. So this we already saw in the earlier slides. Okay. Now we'll check whether this equation is a balanced equation or an unbalanced equation. In the reactant side, we have 1 copper, and in the product side, we have 1 copper. Fine. Copper atoms, fine. In the reactant side, we have 2 chlorine atoms, whereas in the product side, we have only 1 chlorine atom. So number of chlorine atoms are unequal. And in the reactant side, we have 1 silver, and in the product side, we have 1 silver. So number of silver atoms are equal. And in the reactant side, we have 1 nitrogen atom, and in the product side, we have 2 nitrogen atoms. We have 3 oxygen atoms on the reactant side, and we have 3 2s or 6 oxygen atoms in the product side. So since number of atoms of few elements involved are unequal, such a chemical equation has to be an unbalanced or skeleton equation. Now I'm going to balance this, not by trial and error method, but by shortcut method. So let me place A, B, C, and D in front of the reactants and products. And after placing A, B, C, and D, let us assume this equation has got perfectly balanced. So the unbalanced equation is being balanced by placing A, B, C, and D. Thus, number of atoms of all the elements involved in this equation on either side should be equalized, isn't it? Remember, NO3 twice again refers to N2O6. You should never forget that. Okay. Now, let me find B, C, and D, an expression for B, C, and D as before in terms of A. So to do that, I'm just going to use the condition for a balanced equation. Now, copper. Number of copper atoms on either side should be equal. We have A copper atoms, Cu1, right? If there is no number in the subscript of the symbol, you have to take it as 1. There are A molecules of cupric chloride. One molecule of cupric chloride will contain 1 atom. Therefore, A molecules will contain A atoms of copper. And in the product side, we have C copper atoms. Since the equation is balanced, A should be equal to C. So thus, we have written C in terms of A. So instead of C, I can substitute A. Now, as far as chlorine atoms is concerned, we have 2A chlorine atoms on the reactant side and D chlorine atoms on the product side. Since this equation is the balanced equation, the number of chlorine atoms on the reactant side and the product side should be equal to one another. Thus, 2A equals to D. So instead of D, I can substitute 2A. Now, let us go with the silver atoms. There are B silver atoms on the reactant side and we have D silver atoms on the product side. So B should be equal to D. But my aim is to write B in terms of A. We have written C in terms of A. We have written D in terms of A. Now I have to write B in terms of A. We have got B in terms of D. But we know D equals to 2A. With respect to number of chlorine atoms, we have found that. So this implies B is equal to, instead of D, I can take 2A. So B equals to 2A. Now, I have successfully found B, C, and D, an expression for B, C, and D in terms of A. So after completing this process, you just substitute B, C, and D, the expression what you have found for B, C, and D, keeping A as such. So ACuCl2, instead of B, we have substituted 2A. And instead of C, we have substituted A. And instead of D, we have substituted 2A. Now cancelling A, dividing all the reactants and products by A because A is common. So cancelling A, I end up with 1 CuCl2. If there is 1 in front, there is no need of putting 1. So CuCl2 plus 2 AgNO3 gives CuNO3 twice, cupric nitrate, plus 2 AgCl. Now this equation is a perfectly balanced equation. So we have 1 copper atom in the reactant side and product side. We have 2 chlorine atoms here and 2 chlorine atoms in the product side. We have 2 silver atoms on the reactant side and 2 silver atoms on the product side. We have 2 nitrogen atoms over here in the reactant side, and we have 2 nitrogen atoms here, and we have 6 oxygen atoms on the reactant side, and 3, 2 are 6 oxygen atoms on the product side. Thus, we have got the balanced equation. We will see one more example. So we have aluminium reacting with sulfuric acid H2SO4 to give aluminium sulfate Al2SO4 thrice plus sulfur dioxide. It's a gas, so we need a symbol, an upward arrow mark here. Okay, so sulfur dioxide plus water. So this is an unbalanced equation because, and remember, SO4 thrice refers to S3O12. 3 is common for both sulfur as well as oxygen atoms. Okay, so SO4 thrice contains 3 sulfur atoms and 12 oxygen atoms. If you check with the number of atoms of all the elements, we'll check with aluminium. There is 1 aluminium atom on the reactant side and 2 aluminium atoms on the product side. There are 2 hydrogen atoms on the reactant side and we have 2 hydrogen atoms on the product side. We have 1 sulfur atom on the reactant side, whereas here we have 3, here we have 1. So that makes totally 4 sulfur atoms on the product side. And we have 4 oxygen atoms on the reactant side. And here we have 12 In aluminum sulfate, we have 12 oxygen atoms. Here we have 2. So 12 plus 2, 14. And here we have 1. So 15. There are 15 oxygen atoms on the product side. So number of atoms are not equal. Hence, the above equation has to be a unbalanced or skeleton equation. Now let me balance this by the shortcut method. So to balance this by shortcut method, I'm placing as usual A, B, C, D and E. After placing A, B, C, D and E, assume this equation has got perfectly balanced. Remember, S44 thrice again refers to S3O12. So in one molecule of aluminum sulfate, we have 3 sulfur atoms and 12 oxygen atoms. Okay, right. Now, since this equation has got perfectly balanced, the number of atoms of each element on either side should have been equalized. Now again, I'm going to write B, C, D and E in terms of A. So to do that, I'm going to consider the condition for a balanced equation. That is, number of atoms are equal on either side. Now let me start with aluminum atoms. So we have A aluminum atoms on the reactant side and 2C aluminum atoms on the product side. So I have A equals to 2C. Therefore, C is equal to A by 2. So successfully, I have written C in terms of A. Now 2B is equal to 2E. You have 2B hydrogen atoms on the reactant side and 2E hydrogen atoms on the product side. So they are equal. So cancelling 2 on either side, I have B is equal to E. But my aim is to write B in terms of A, but I have got B in terms of E. Let it wait. We'll do it ultimately. Now let me go with sulfur atoms. There is one sulfur atom in one molecule of sulfuric acid. And in this reaction, in this balanced equation, in fact, we have B molecules of sulfuric acid. So that makes the total number of sulfur atoms to be B. So B into 1 is B. So we have B sulfur atoms in the reactant side. And in the product side, we have, see, there are 3 sulfur atoms in one molecule of aluminum sulfate. In this balanced equation, we have C molecules of aluminum sulfate. So in one molecule of aluminum sulfate, there are 3 sulfur atoms. Therefore, in C molecules, there has to be 3C. So 3C sulfur atoms. So here we have 3C sulfur atoms. Okay. And sulfur dioxide. In sulfur dioxide, we have D sulfur atoms. So total number of sulfur atoms in the product side is 3C plus D. And in the reactant side, it is B. So they should be equal because it is a balanced equation. So B equals to 3C plus D. So I have got a linear equation in terms of C and D. Okay. And instead of C, I'm going to substitute A by 2. So I have B is equal to 3A by 2 plus D because my aim is to write B in terms of A. So I got B in terms of C and D. So let me introduce A here. So 3A by 2. To eliminate this fraction, I'm just going to multiply all the terms of this equation by the denominator of this fraction, that is nothing but 2. So 2 into B will give me 2B. 3A divided by 2, when multiplied with 2, you will have these two cancelling each other. So I end up with 3A and 1 into 2 is going to be 2D. So I'll end up with an expression 2B is equal to 3A plus 2D. Let me take this expression as number 1. And number of oxygen atoms, we have 4B oxygen atoms on the reactant side. And we have 12 oxygen atoms over here in one molecule of aluminum sulfate. Therefore, in C molecules, we will be having 12C oxygen atoms. Here we have 2 oxygen atoms in one molecule of sulfur dioxide. There are D molecules. Therefore, there has to be 2D molecules of oxygen. So here we have 12C oxygen atoms. Here we have 2D oxygen atoms, and here we have E oxygen atoms. Therefore, 4B should be equal to 12C, number of oxygen atoms in aluminum sulfate, that is C molecules of aluminum sulfate, 2D, number of oxygen atoms in D molecules of sulfur dioxide, and E, number of oxygen atoms in one molecule of water. Okay. Now let me write C in terms of A. Let me substitute A by 2 for C here. So 12 into A by 2. So I have 4B is equal to 12 into A by 2 plus 2D plus B. So I can cancel 2 and 12. So I get 6A, isn't it? So I end up with 4B equals 6A plus 2D plus B. Let me take B to the left hand side. So I have 3B is equal to 6A plus 2D. So 4B equals to 6A plus 2D plus B. Taking B to the left hand side, I get 3B is equal to 6A plus 2D. Now let me solve these two equations 1 and 2 and find what is B in terms of A, and let me find what is D in terms of A. So solving 1 and 2, just like you would have solved linear equations in mathematics, you have to solve these two equations. The solving steps are shown in the next slide. So solving 1 and 2, we get B is equal to 3A. So we have B is already equal to E, and we have found B to be equal to 3A. Now since B and E are equal to one another, so B is equal to 3A and E should also be equal to 3A. Therefore, I can write B and E are equal to 3A. So B and E are written in terms of A, C is written in terms of A, and D is equal to 3A by 2. So D is also written in terms of A. Now we'll show the solving step in the next slide. So just remember these two equations. So we have 2B equal to 3A plus 2D. This is equation 1. And 3B is equal to 6A plus 2D. So the two equations are written here. So what I'm going to do is I'm going to subtract the second equation, 2 minus 1. I'm just going to subtract these two equations. Okay. So 2 minus 1. I'm going to subtract the first equation from the second. I'm sorry. I'm going to subtract the first equation from the second equation. So 2 minus 1. So 3B minus 2B will give me 1B. And 6A minus 3A is going to give me 3A. 2D minus 2D, 0. So these two will cancel each other on subtraction. So I end up with B is equal to 3A. So that's what we found in the earlier slide. And since B and E are equal, B is equal to 3A as well as E should also be equal to 3A. Now let me substitute B is equal to 3A in either of these two equations. So substituting B is equal to 3A in one, I get, instead of B, let me put 3A. So 3A into 2 is 6A. So 6A is equal to 3A plus 2D. My aim is to find what is D. So take 3A to the left hand side. So 6A minus 3A equal to 2D. Therefore, D is equal to 3A over 2. So hence, I get B is equal to E is equal to 3A. C is equal to A by 2. And D is equal to 3A by 2. Now let me rewrite the equation. So this was the equation A times Al plus B molecules of sulfuric acid, C molecules of aluminum sulfate, D molecules of sulfur dioxide, E molecules of water. Let me substitute B, C, D, E, keeping A as such. So I end up with A molecules of Al plus 3A molecules of sulfuric acid and so on. You can see A is common in all the terms. So let me divide all the reactants and products by A to cancel it. There is no need of showing the division, so we can just literally cancel. So after cancelling this, you'll have something like this. So we have cancelled A. So we have 1 Al, 3 H2SO4, 1 by 2 Al2SO4 thrice, 3 by 2 SO2 plus 3 H2O. To eliminate the fraction, we have two fractional values here. So to eliminate the fraction, I have to multiply all the reactants and products by the LCM of their denominators. So both the numbers are same. So the LCM is 2. LCM of 2 and 2 is 2. So multiplying all the terms by 2 throughout. So I have 2 Al plus 3 2s are 6 H2SO4. So if I multiply this by 2, 2 and 2 will cancel each other. So thus you have 2 cancels. Thus we have 1 here. So 1 Al2SO4 thrice plus, again, when I multiply this by 2, 2 gets cancelled. I have 3 SO2 and 3 2s are 6 H2O. Now this equation is a perfectly balanced equation because there are 2 aluminum atoms on the reactant side and 2 aluminum atoms on the product side. There are 12 hydrogen atoms on the reactant side and we have 12 hydrogen atoms on the product side. There are 6 sulfur atoms here and we have S3 here, and we have 3 sulfur atoms. Totally, it makes 6. So we have 3 sulfur atoms in aluminum sulfate and 3 sulfur atoms in sulfur dioxide, 3 molecules of sulfur dioxide in fact. So that makes totally 6. And there are 24 oxygen atoms on the reactant side. So here we have 12. Here we have 6. 12 plus 6, 18. 18 plus 6, that makes totally 24. Thus, we get a balanced equation. Dear students, please practice the shortcut method for several equations until you get acquainted with it. I think it's going to be really helpful to you. Thank you then. Have a nice day further. Meet you in the next video session. Bye-bye.